Hello everyone, welcome to this session. So, in this session, we will get a fundamental idea about Simscape toolbox. So, once we have installed and download the MATLAB, so once we double click on the MATLAB icon, so this type of interface will open. Here, you will see so many type of options are there. Now, you can see this is the option called Simulink. If we just click this, so this screen will appear. Here you can choose you want to create a blank model or blank subsystem. So I want to create a blank model, so I will click here. So this is the blank Simulink window that will create. Here you can see there are so many options. So in upcoming sessions we will see what is the needed for those options and how we can build models. In this session, you can check this library browser where Simscape toolbox is present. As the MATLAB covers various domains of engineering like mechanical, electrical, aerospace, and other domains as well. So for different purposes, you can see there are different libraries are available. Like aerospace block sets is available, audio toolbox is available, then communication toolbox is available, deep learning toolbox is available. So for various purpose, there are different toolbox are there. Here you can see if we just go below, drag this below, you can see there is an option called Simscape. So inside the Simscape library, we will find you can see there are total 7 sub libraries are there. Inside the foundational library, you will find based on the domains, there are electrical, gas, hydraulic, isothermal liquid, magnetic, mechanical, moist air, physical signals, thermal liquid, two-phase fluid. So based on the different domains, there are different blocks are available. Like if we just go for the electrical, you can find under electrical, there are also 3 options are there, like electrical elements, electrical sensors, and electrical source. If we just go for electrical elements, you will find all the electrical elements that is required for modeling, like capacitor, diode, resistor, op amp, inductor, transformer, open circuit. You can see here open circuit. Also, you will see motor, the rotational electrochemical converter. You will find so many blocks are there. Similarly, if we go for the let's say mechanical, inside the mechanical sensor, you will see ideal force sensor, ideal rotational sensor, motion sensor, ideal torque sensor. Inside the battery, so these are the sub libraries, these are the libraries, right? So if we just go for the battery, you will see inside the battery there are BMS, cell balancing. For cell balancing, all the required blocks, that is passive cell balancing block is present. Inside the cells, if we just go here, we will find batteries, table based batteries, and different type of batteries are available. Let's say if we just take this battery here, so once we paste the battery here, so there are 2 process. You can drag this, or you can just double click here and search for the name. So like this name is battery, right? So once I search for the name like battery, so under this the battery will come under this one, this electrical, under then sources, under this battery will come. So from here also we can take the battery. If we want to read about the battery, what it does and how it does, so we can go for the description. And inside description, you can read about this battery block, like this block models a battery. If you set the battery charge capacity parameters to infinite, the block models the battery as a series internal resistance and a constant voltage source. And then it done the operation. Here inside here you will find so many options for different parameters what you want to give. Based on that parameters, the battery will behave like that. So similarly for all the other blocks as well, the process is same. We need to take the block, and there after double clicking on it, we can select the parameter, and if we want to read about the description, we can go for the description option. Now let me tell you about a fact. Last year, Maruti Suzuki itself sold 16 lakh of cars in India. So there are so many numbers of car manufacturer present in globally. So if we just consider the number globally that is sold, the number is very large, and the tailpipe emission that is happening due to those lots of vehicle, the amount is very huge. And majorly that is one of the most important reason for emitting of greenhouse gases and this greenhouse effect, causing this greenhouse effect, and also other environmental degradation. When this climate change is the biggest concern, the utmost sustainability that we need in terms of fossil fuel combustion, we need to go for e-mobility. Go for e-mobility to go for electric vehicle or zero emission vehicle, so that there is no greenhouse gases or emission and there is a cleaner environment can get. In this transition from normal or regular IC engine vehicles or internal combustion engine vehicle to this complete electric vehicles or zero emission vehicle, zero EV, ZEV. In this process, the hybrid electric vehicles, that is basically the combination of both the conventional vehicle and the electric vehicle, that takes the place. So for this electric and hybrid technology to deliver superior performance, efficiency, all the subsystems have to work seamlessly and in unison every time and all the time. To ensure this level of precision and reliability, this modeling and simulation play a very crucial roles during this design and development cycle of electric and as well as for hybrid electric vehicle. Now, this Simscape MATLAB Simulink toolbox for modeling physical systems is an ideally suited platform for developing and deploying models for systems and subsystems that are critical for hybrid and as well as for electric vehicles. Now, in this design, engineering, and production process of EVs and hybrid electric vehicles, it needs a confluence of many disciplines and topics areas such as combustion engines, mechanical systems, power electronics, embedded systems, embedded control, motor technology, electrochemical energy conversion, embedded software development. Moreover, a complete mathematical modeling and simulation play a very crucial role in this development, design, and production process. So this Simscape library uses the physical network approach, which is very intuitive, a technique that will look familiar to the users who have a basic engineering idea. So it is very comfortable for them. So there are ready-made blocks are available if we want to design or develop any kind of subsystem or components of EVs or the whole EV or hybrid electric vehicles. We can go for these blocks that are present inside the Simscape, inside different sub libraries. We can go for the blocks and we can take it, and after taking it we can set the parameters based on our requirement, and we can connect it, and we can meet our goals. So this is the prerequisite knowledge that is needed to go for the rest of the course. So in the upcoming sessions, in the upcoming videos, we will see different component modelings and also the hybrid electric vehicles and electric vehicles modeling using MATLAB and Simscape library. So thank you everyone.